Hello there. Let's do some compound inequalities. Actually, absolute value inequalities. We're going to start out with the ones that you know how to do, and then move on to some new ones that I just sent. So this one is straightforward. You know the distance is greater than 7, so the midpoint is 0. Oh, sorry, less than 7, so it's going to be, here we have 7, -7, and it's this area in between. We have the absolute value is less than 8, so that's the same thing. Less than, okay, greater than. This is a compound inequality where the distance is more than 7 away, so that would be, boom, more than 7. Okay, now let's look at some that I just assigned, so it's at 0. Okay, great. I want to do this over here. So this is, the distance is less, this is an intersection. So we could do case 1 and case 2 of absolute value. First off, we would just follow this as is. Case 2, you make it negative, and if you make it negative, you flip the sign. -3, -3, x is less than 4. So here we'd have 4, and it's going this way. -3, -3, x is greater than -10. -10, boom. And what would the midpoint be? The midpoint, it's just like with absolute value transformations. It's what makes this equal 0. So the midpoint is here. What's the distance? All the way to the edge is 7. And it can be any number in here. So that is this one. Go ahead and give this a try. Problem number 3. This is also be an intersection. Let's do a union now. So I know this is a union because the distance is greater than 4, so it's going to be going out that way. It's more away. It's farther away from it. So I'm going to do the formula x minus midpoint is, I used to do equals a distance, but now we realize this could be less than, greater than, whatever sign the distance. So the midpoint would be -6, which is here. We want things that are 4 away from it. 1, 2, 3, 4, and it can equal it. So it'd be 2, 1, 2, 3, 4. And we want things that are more than 4 away. So it can't be exactly 4. Oh, it can be exactly 4 away, but it also can be more than that. So remember, when in doubt, case 1, case 2, we just follow it exactly as is, greater than or equal to 4. W plus 6. I want to make this -4, but then I need to switch the sign. -6, -6. W is less than or equal to -10. That's what we have. -6, -6. W is greater than or equal to -2. That's what we have. Okay, so this one's a great one to do. Okay, let's try problem type 4. I don't know if this one is like a special case or what it is. Ooh, interesting. I just see that our coefficient is negative, right? So let's do case 1. 10 minus 5u is less than 5. Ooh, I'm intrigued. 10 minus 5u this is going to be -5, and I'm going to flip the sign, okay? Subtract 10, -5u is less than -10. When I divide by -5, I flip the sign. U is greater than 2. And then this would be 5u is greater than -15u. When I divide by negative is less than 3. So greater than 2, less than 3. Oh, that's a thing. Greater than 2, less than 3. Oh, it's just like a little baby. Boop. And that kind of makes sense. So if we said it was x minus midpoint, so here we have like, because it's like negative, negative, and in the absolute value, It's the same thing really as like this, which I know you're not going to really believe. But if I divide this all, I would have u plus 2 less than 1. So did I do something wrong? Just dividing it out. This would make me think the midpoint is negative 2, but it's not. Okay, let's just click solve. And if I did this wrong, oh, it's 1 to 3. There's something I did here. Uh, the 3 was right, the 2 was wrong. So 10 minus 5u is less than 5. Oh, okay, yeah. When I subtracted 10, it's supposed to be negative 5u is less than negative 5. My subtraction was wrong. U is greater than 1. Okay, then that makes sense. The midpoint was 2. Okay, bang. Let's try what some of these other ones might look like. Okay. Yeah, these are just intersections. Are they always? What if we have a negative that's greater than? Okay, good. There's a union. That's practice. Okay, then I sent you an absolute value one where it was like in a word problem. Okay, yeah. Let's see this. Oh my Lanta. Okay. A manufacturer produces cans of soup to pass inspection. You must have 4 ounces or plus or minus. Oh, I actually love this. So plus or minus. If the can doesn't meet the requirement, it fails. Okay. So it's going to be, do they give us a variable? Acceptable soup. Can I just do X? Oh yeah, X minus like the goal, which is 4, and it needs to be within 0.5. Like that's the tolerance. This is actually great. I know it looks like a lot of words, but this is amazing practice. So X minus midpoint is or less than or greater than the distance. So another way you could say this is X minus the goal or the expectation is equal to, less than, greater than, whatever. The like allowable difference. Another way they call that is like the tolerance. So what will they tolerate? They're going to tolerate, in this case, a half an ounce off. Okay, so we solve that in 2 ways. So that would be case 1, case 2. I guess you kind of know what it would be. It needs to be, fine, I'll just do it. X minus 4 less than 0.5, add 4. So it needs to be less than 4.5 or equal to, and it's going to be greater than or equal to 3.5 because that's what a half the other way is. So I could put it in between. Wonder if I could, whoops, use the word and, because I think I could also do in between. We'll see if they accept it like this. Okay, then I have, and it can equal it, plus or minus. Suitable capacity inspection if it is greater than or equal to the bottom one and less than or equal to the top one. Let's check that. Run it to not start a number with a decimal point. Ooh, I like that. Like throw a 0 in there, 0.5. Sick. Okay. Um, is this like the same soup problem again and again? Okay. Then we got palm trees. This one I can just do quickly. Okay, they want it to be 3 feet plus or minus 1. Okay, so that's going to be they guarantee it's going to be that much within. So it should be within 3, 0.5. Okay, I'm going to start with 0. So now let's solve this. I wonder if I can put it like as an in-betweeny. Okay, we have 2.5, 3.5, bang. Okay. Wonder if it's like, if they tell you, oh, wait. Ooh, you guys got to read. This said, find it to find the unacceptable heights. Okay, so I almost did this wrong. So it would be unacceptable when it is, got to flip it. Oh, that's also wrong. X minus 3 is going to be greater than 0.5. So that's wrong. It's going to be less than X is less than 2.5. That's unacceptable. Or X is greater than 3.5. Yeah, you guys got to read this. Otherwise, I was about to get it wrong. Okay, so it needs to be a union. So everything on this end is the stuff that the refund will happen. So they're asking which ones will be refunded. The palm tree will not meet the guarantee. Oh, I love that it reminds you here. If it grows to be less than 2.5 feet or greater than 3.5. Okay, we check that. We get those, no feedback. We're rock stars. Okay, so let's see who are going to be the first couple people to get this. Ooh, only some. You got to do 71% of you in this class currently are ready for problem 3. And then you go 4, 5. Lastly, let's just do one last one. Just because why not, you know? Let's come up with the inequality given this graph. Okay, so I want to find, it's going to be x minus midpoint. And then it's like some sign distance. Okay, so that's like the thing I'm going to use. In this case, I know it's going towards, so it's going to be less than the distance. Midpoint, is 0. So x minus 0 is less than or equal to 5, right? So you could just say the absolute value of x is less than 5. Bam. Okay, this is greater than 2. Oh, there's not even an extra step. Midpoint is 0. The distance is greater than 4 or equal to, bang. Okay, so all of these are pretty straightforward. I wish there was one where it was like, it was translated to left or right one, but okay. Yeah, so that's good. Happy hunting.